Everyone, welcome to explanation. So in last video we covered serializability, and we also checked a question about whether it is a conflict equivalent or not. Okay, so in this video we'll be covering our next topic, which is conflict serializability. Conflict serializability. Okay, so what is the conflict serializability? So we can write the definition on non-serial schedule is conflict serializable if it can be transformed into serial schedule. It is serial schedule by swapping non-conflicting operations. So this already we solved this question. We are going to swap the non-serial conflicting operations, and if we can swap this, and after that, after swapping, if we can transform a schedule into a serial schedule, it is known as conflict serializable. Okay, it is very simple. We just convert a schedule into a serial schedule, a non-serial schedule into a serial schedule. So what are the steps? So the steps are, first of all, we have to first of all we'll check for the conflict serializable, and then we are going to construct precedence graph. Okay, I'll solve this question and show you. First of all, we have to construct a precedence graph here, and in this graph the transactions are the node. Okay, the transaction are the node. For example, this is T1 and this is T2. So this is a transaction, this is a transaction, and the edge represent, okay, the edge represent the conflict. If a conflict is occurring, we are going to represent it with a edge or with a arrow. Okay, second is, after constructing the precedence graph, we are going to check for cycles. Like in this graph, if there is any cycle in the graph, okay, if there is a cycle, it means that the schedule is not conflict serializable. If a cycle comes in this precedence graph, it means that our schedule is not conflict serializable. It means that we cannot convert this schedule into a serial schedule. But if there is no cycle in the precedence graph, it means that the schedule is conflict serializable, and it means that we can transform this schedule into its equivalent serial schedule. Okay, so let's start with the question. This is a very important question, so I hope you understand this question. So the question is, let us consider a transaction T1, T2 and T3, okay, having the operations like read of X, after that we are having read of Y, after that we are having read of X, we are having read of Y, we are having read at Z, we are having write at Y, we are having write at Z, we are having read at Z, we are having write at X, and we are having write at Z. Okay, so this is a schedule having transaction T1, T2, T3. Now we have to check this. We have to check that whether this schedule is a conflict serializable or not. If it is a conflict serializable, so after that checking, if it is a conflict serializable, we can get a serial schedule, equivalent serial schedule for this. Okay, so you can see this is a non-serial schedule. Okay, so first of all, let's check whether it is a conflict serializable or not. So as I told you, we have to check for the non-conflicting pair and draw the precedence graph. So here let us make the nodes here T1, T2 and T3. Now let's check the non-conflict pair one by one. First of all, we are going to check this. See, this is the R of X. So what will be the conflicting pair for this? We are going to check for the conflicting pairs. Okay, we are going to check for the conflicting pairs, and then we are going to draw the graph. Sorry. Okay, so here first of all, let's see Rx. So what are the conflicting pair for Rx? Okay, so the conflicting pair for Rx is W of X. So let's check whether W of X is present in any other transaction or not. So is there W of X? No, 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 no. It is in the T1 transaction, so it doesn't work for us. In the same transaction, no need to check. Okay, now let's go to this. We check this. Let's go to this. R of Y. So what will be the conflicting pair of R of Y? Okay, what is the conflicting pair of R of Y? We'll check this. It is R of W of Y. It is W of Y. So you can see W of Y, is it in T2? No. Is it in T1? No. So if it is in T3, it doesn't matter, because in the same transaction, we'll not consider this. Let's check for another one, R of X. What is the conflicting pair for R of X? It is W of X. Is this in T3? It doesn't matter. Is this in T2? No. Is this in T3? Yes, it is in T3 here. So we are going to draw a line from T3 to T1. Okay, now let's check the another. So here we have RY. So what is the conflicting pair of RY? The conflicting pair of RY is W of Y. So is this in any other transaction? Yes, it is in T3. So we are going to draw a line from T2 to T3. Let's check for RZ, WZ. It is in T2. It doesn't matter. It is in T1. Yes. So we are going to draw a line from T2 to T1. Let's check for other, W of Y. What is the conflicting pair of this? So as I told you, the conflicting pair of W of Y will be both R of Y and W of Y. Okay, so is this in T1 and T2? No, it is not in T1 and T2. Let's go to W of Z. So the conflicting pair of W of Z will be R of Z as well as W of Z. So is this in any of this? R of Z? Yes, it is in T1. So T2 to T1, we have already drawn a line. R of Z, W of Z, T2 to T1, yes, we have already drawn a line. After that, we'll see this. So no other transactions are left in T2 and T3, therefore no need to check for this. And remember, while checking for this, you cannot go up. You always have to come down and check for the other operation. Okay, so this is our required precedence graph. This is our required precedence graph. So can you see, is there any cycle here? Cycle means like this, it should form up. No, there is no cycle. You can see here, as two edges are going to a same node, it doesn't form any cycle. It means that this is a conflict serializable. So if it is a conflict serializable, there should be a equivalent serial schedule for this. Now we have to check for the serial schedule for this. So what is the rule? What is the rule? We'll check the in degree at any node. In degree means the number of edges that is pointing toward a node. So if the in degree is 0, we are going to remove that. Okay, so we can say which node has in degree 0? This one has an in degree of 0 because it doesn't have any edge coming here. So we are going to, okay, so what is its in degree is 0? Yes, so we are going to remove this one. We are going to remove this one. If it is removed, the edges will also be removed. We are going to remove this one and write here T2. Now what will be the next node whose in degree is 0? So you can see the in degree of T3 is 0. So we are going to remove this one and write the value and write here T3. Next T1, the in degree is 0. So we are going to write the T1. So this is the equivalent serial schedule for this transaction. It means that in serial schedule, it will happen like this. First of all, T2 will occur, then T3 will occur, and then T1 will occur. So for this question, this is the corresponding serial schedule. That was all about conflict serializability. In the next question, in the next video, I'll come up with some other questions. Till then, stay safe and thank you.